Good morning. Uh, Today, I would like to emphasize some of the concepts or some of the ideas that we discussed last time, or part of the things that we discussed last time. If you remember one of the things that we discussed last time is the uncertainty that we encounter in when using measuring instruments. And if you remember, I told you that if you are using a meter ruler, then any measurement that you take with the meter ruler is going to be uncertain by an amount of zero point 0.1 centimeter. Okay, if you remember that. Sorry. I've also told you that if you use a vernier to measure a lens, then any measurement you take with the vernier is going also to be uncertain with an amount of 0.01 centimeter. If we do a measurement with a micrometer, then the lens is going to be uncertain by a value of 0.001 centimeter. If you remember this from last time, okay, this uncertainty, okay, it is called absolute uncertainty. Okay, this uncertainty in a measurement, okay, or in a measured value is called absolute uncertainty. And typically the symbol used to indicate absolute uncertainty is delta, is the letter or the Greek letter delta, capital delta actually. Okay, so this is from last time. So let us try this. Okay, we have this lens or this piece of paper, and we would like to take or to measure the length of this piece of paper. Okay, so we are going to lay it flat parallel to the meter ruler. Okay, we are going to set one side next to the zero or any other thing or any other value, and we are going to take the measurement of this part, right? This is how we typically use a meter ruler. So let us start counting. So this is 2, this is 2.1, 2.2, 2.3, and this is 2.4. So the reading is closer to 2.3 centimeter. So it is 2.3 centimeter, the length. Okay, what about the absolute uncertainty? Delta L. Since it is a meter ruler, it is going to be 0.1 centimeter. Okay, is how we report the absolute uncertainty. So why absolute uncertainty? Uncertainty is important in our discussion because it is going to be a recurring theme in the exam papers of paper 3 and paper 5. You will continuously get things like calculate the absolute uncertainty, calculate the fractional or percentage uncertainty. So I would like always to make sure that you understand it well. Okay. What about using a protractor to measure an angle theta? Okay. For example, we have here a protractor and we have an angle. I marked it as theta over here. Okay, this is the angle, and we are trying to take a measurement of it using the protractor. So if you look closely uh, at the diagram, okay, let us see. This is 30 degrees, okay, 31, 32, 33, 34, and this angle is 35 degrees, okay. So what is the absolute uncertainty in this measurement? It is going to be 1 degree, okay. It's going to be 1 degree, okay. What about if you are encounter taking a reading from an analog meter? Okay, an ammeter is typically used to measure current in a circuit, in an electric circuit. Okay, so how typically we can identify the absolute uncertainty in a measurement? Well, if you remember, we said that absolute uncertainty is always related to what we call the least scale division. What? Least scale division. What does the least scale division means? It means the smallest, least, sorry, least scale division is the smallest unit that can be measured with a certain scale. Okay, so if we have this ammeter, or yes, we have this ammeter, how can I define or find out the least scale division? So this is how we are going to do it. We have this scale or this mark, it is the 0 mark. Okay, we have 1 milliamp, 2 milliamp, 3 milliamp, 4 milliamps, and here is 5 milliamp. Okay, let us take a closer look at the scale. So from here to here, it is 1 milliamp. Okay, 1 milliamps. So how many small divisions is between 0 and 1 milliamp? If we count them, it is 1, 2, 3, 4, and this is 4, 5 small division. So we have 5 divisions. Okay, now let us find how much one division is equal. So one division is what? Is 1 milliamp divide 5 divisions. It is 0.2 milliamp. So the least scale division above is 0.2 milliamp. So how is delta or the absolute uncertainty in this scale is related to the least scale division? Okay, we said that delta or the uncertainty or the absolute uncertainty is equal to the least scale division divide 2, okay, which is 0.2 milliamps divide 2 is equal 0.1 milliamp. Okay, so in conclusion, any measurement that you are going to take with this ammeter or milliammeter, it is going to be uncertain with a value of 0.1 milliamp. Okay, let us take the reading over here. Let me clear this. So this is 1 milliamp. Okay, how many small divisions? It is 1.2, 1.2, this is 1.4, and this is 1.6 milliamp. So the reading is going to be 1.6 milliamp. Okay, and we are going to be uncertain in this measurement with an amount of 0.1 milliamp. Okay, now let us try another scale. Let us practice on another scale. Okay, we have a voltmeter over here. Okay, now we would like to calculate this least scale division. What is the least scale division? We said that it is the smallest value that we can measure accurately using this scale. Okay, so we know from this point to here we have zero point 0.2 volts, right? How many divisions? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then divide by 10. Then it is 0.02 volts. Then the least scale division of this scale is 0.02 volt. What is delta V? Okay, it is the least scale division divide 2. Then it is 0.02 divide 2, it is 0.01 volt. Okay, what is the reading on this scale? Okay, let us clear this again. So we have here 0.2, here is 0.3 point. We know each small division is uh, 0.2, sorry, 0.02. So this is 0.32, this is 0.34. So the reading is 0.34 volts, okay? And each measurement we carry out with this voltmeter, it is going to be uncertain with this amount, okay? Delta V is going to be that. What if we have a digital scale like this? So this is a voltmeter, a digital voltmeter, okay? What is the reading? It is very simple. We can just read the scale. 12.034 volts. Okay. What is the least scale division, or what is the what is the uncertainty in this measurement? In the case of a digital scale, the absolute uncertainty, it is 1 unit of the least significant figure. 1 unit of the least significant figure. Okay, then this value is going to be the 0.001 volt. 0.001 volt. Okay, this is how you identify the uncertainty in a digital scale. It is going to be 1 unit, okay, of the least significant figure. The least significant figure is this one, and 1 unit of it. So 0.01 volt. Let us try it over here. Okay, we have a measurement over 408 ohms. So what is the uncertainty in this measurement, or what is the absolute uncertainty delta R in this measurement? It is 1 unit of the least scale, the least significant figure. Okay, this is the least significant figure. Okay, then it is going to be 1 ohm. So any measurement, or this measurement, is certain by how much? It is certain by 1 ohm. Okay, I hope this is clear for you. Okay, what if we got some kind of readings? They gave us reading in a table. Okay, can we identify the uncertainty in a table, or readings in a table? Yes, we can do that. For example, what is the uncertainty, or the absolute uncertainty? In the length and in the time. Okay, if we find it like this, then it is like a digital meter. It is like a digital meter. It is going to be 1 unit of the least scale, least significant figure. It is going to be 1 unit of the least significant figure. Okay, then it is from here, it's going to be zero point 0.1 centimeter. Then most probably this measurement was carried out by uh, a meter ruler. Okay, what about the time? Again, it is 1 unit of the least significant figure. 1 unit of the least significant figure. Okay, so it is going to be 0.001 second. So either we get it from a scale, a measuring scale, like a vernier, like a micrometer, like a meter ruler, a digital meter, an analog meter, whatsoever. We know how to identify the absolute uncertainty. If we get it in a in a table like this, or a tabulated results, then we also know how to identify the absolute uncertainty. Please make sure that you understand these very well, because it will make life easy for us when we go and start solving for paper 3 and paper 5. Okay, so not, as we mentioned, not every quantity or physical quantity we can directly measure using a physical instrument, right? For example, if we were told to calculate the circumference of a square, we are asked to calculate the circumference of what? Of a square. Then we don't have an instrument to directly measure the circumference of a square. But what we typically do, we are going to measure the length A, okay, and the other side B, and then do the mass, right? So the circumference, sorry, C is equal to A زائد plus 2B. Okay, now the circumference is 2A plus B equal to 4.3, 4.3, 4.3 and 4.6. 4.3 plus 4.6, it is 8 2 times 8.9. It is going to be 17.8 centimeters. Okay, this is circumference. So what is the absolute uncertainty in this value? Okay, so this is a rule. This is kind of a rule. If any physical quantity is made up of two values, two or more values, that they are just added together, added or subtracted from each other, it doesn't matter, then the absolute uncertainty is simply the arithmetic addition of all the absolute uncertainties. So we have delta A and delta B. So delta C is simply 2 delta A plus 2 delta B. Okay, we are given it is measured by a meter ruler, 0.1 centimeter. So the absolute uncertainty equal delta C is equal 0.4 centimeter. What if the physical quantity was C is equal to A plus 4 B minus 6C, sorry, something like 6, sorry, D. Okay, then delta C is going to be 2 delta A زائد 4 delta B plus 6 delta D. Okay, this is how we calculate the absolute uncertainty if the measured values are just an addition or subtraction from each other. Okay, what if the values are multiplied together? Okay, as an example, let us calculate the area. So the area is equal A times B, right? 4.3 times 4.6. Let us do the calculation. So 4.3 times 4.6 is equal, it is 19.78. 19, sorry, 19.78. And the unit is centimeter square. Okay, then how do we calculate delta A? Well, the formula that you should always remember that if the physical quantity we are interested at calculating, the absolute uncertainty is the product of two or more values, then we calculate it like this. So delta A over A is equal delta small a over A plus delta B over B. Okay, if we want delta A itself, it's equal delta A over A plus delta B over B times A. Okay, let us substitute. This is 0.1 divide by 4.3 plus 0.1 divide 4.6. We multiply by 19.78. Okay, let us do the math. Bracket 0.1 divide 4.3 plus 0.1 divide 4.6, okay, is equal times 19.7a, 0.89. So it is 0.89 centimeter square. Sorry, square, it is square, it's not cube. Okay, so delta A is 0.89 centimeter square. So now be careful with this. Be careful with this. We are always instructed that we should round, okay, the value or the absolute uncertainty to one significant figure. We should always round it to one significant figure. Always round the absolute uncertainty to one significant figure. So rounding this to one significant figure, delta A is equal 0.9 centimeter square. 0.9 centimeter square. Okay. Now we go back to A. Now, what is A? A we calculated as 19.78 centimeter square. When to report the final answer for A, okay, we are said or we are recommended to reduce it to the same number of decimal places as in A. Reduce or round A to the same number of decimal places as in delta A. Therefore, A is equal 19.8 centimeter square. Delta A is equal 0.9 centimeter square. Okay, just keep all this in mind. Okay, don't be worried. As we practice more, as we solve more, okay, you will get used to it. Okay, you will get used to these kind of things. So don't worry. Okay, so here we have said that if we carry a measurement, okay, using an instrument like a vernier, like a micrometer, a meter ruler, a protractor, whatsoever, okay, this is how we can calculate the absolute uncertainty. Okay, but as we go through paper 3, okay, one way of doing things is going to be a little bit different. Okay, for example, this is a typical question, question 1 in paper 3. Okay, just let us see how we are going to calculate the uncertainty or the absolute uncertainty in this context. In this experiment, you will investigate the oscillation of a pendulum. Okay, we have a pendulum. Set up the apparatus. Okay, I don't care for this now. The length L of the pendulum is the distance between the bottom of the wooden block and the center of the adhesive putty. Adjust the length of the spring so that the L is approximately 53 centimeter. What he recommended us is that we should fix this length. Sorry. Sorry. To be roughly 53 centimeter. Okay. Then he asked us to measure and record L. Measure and record L. So this is how you should answer this part of the question. Always, okay, in paper 3, you will encounter something along the line of this question. You are given a physical quantity, okay, and you are asked to take a measurement of it. It could be the length, it could be the diameter, whatsoever. We are going to see, but let us see for the length. So this is the recommended way how to answer this question. Okay, take 2 or at least 2 readings for L. Use your meter ruler and take 2 measurements for the length. Okay, so for example, we get L first time, we get it like 53.9 centimeter. Okay, we try it one more time. This is very important. Okay, if you take it one reading only and you report it, you are going to lose some marks. So he wants you to show him or tell him that you have taken at least 2 measurements for the lens. Is how they like this question to be answered. So take L1 and L2, 52.3 centimeter. Okay, then which L are we are going to report? L is the average. What we are going to report is L the average. 53.9 plus 52.6 divide 2 is 1.3, 1.65. Okay, let us do the math. So it is 53.9 plus 52.6 divide 2. 53.25, 53.25, 53.25 centimeter. Okay, this is our measurement. Okay, since we know that measurement using a meter ruler can only be accurate within, okay, let us keep it for now. Don't mention that here. Okay, so we got it here. So what if we were asked to calculate the absolute uncertainty in this case? We were asked to calculate the absolute uncertainty in this case. So simply, this is going to be what? We are going to do it like this. Delta L is equal maximum value, maximum minus average. Delta L, the absolute uncertainty in this kind of measurement, when you take more than one reading, it is going to be the maximum minus the average. So in those two readings, what is the maximum value? Or what is the highest value? It is 53.9. So it is 53.9. What is the average? 53.25. Do the math. 53.9 minus 53.25.65. Now, as recommended, we keep it to only one significant figure. Then delta L is equal 0.7 centimeter. Then we reduce L to 1 decimal place. Okay? Compatible with the number of decimal places in this value. Then it is going to be 53.3 centimeters. Okay? So please revise this carefully. Okay? Go through this again yourself. Okay? Do not be worried as we start solving the exam. Okay? Things are going to be more clear. Okay? So just don't get worried about this. As we practice, it is going to be easier. Okay? But important, keep this or what we have mentioned today, okay, in mind. Okay. Good luck and see you.